I've had a few people contact me saying that they were unsure how to answer some of the questions, so I'm going to go through them a bit at a time. This is page 64 of Sequential Systems, and this is a question about making this set of light turn on in a specific order. So you can see here all the lights are off, then got a blue light on, then blue and red come on, then blue, red and green come on, and then it goes back. So it asks you some simple questions first, but there's some easy mistakes to make here. First thing, it's saying how many outputs are required. So that's how many things switch on and off. So it's really clear to see from the diagram that the amount of outputs that you need are 3. You need a blue light that switches on and off, a red light that switches on and off, and a green light that switches on and off. So you've got 3 outputs. Okay. This is where a few people made mistakes. So how many different output patterns are required? Now there's a pattern here because blue's on, there's a pattern here, blue and red, and blue, red and green. And a few people put 3 for this. But you must remember that everything being off is also a pattern. So how many different output patterns are required? That's 4 patterns. There are 4 different patterns of the lights being on or off that you need to produce. Now it's asking me how many inputs are required to generate this number of combinations. Now I know that for 4 combinations it's 2 inputs. If you want to find out how you work that out, you can go to the Educas ebook, and it's chapter 6 on logic, which is, we've looked at that before, but that will explain how you do this. There's a simpler way in the question for you to know this, and if you look ahead in the question, they give you the truth table that they want you to fill in, and it tells you here 3 outputs, 2 inputs. So you can kind of know and check for yourself that there are 2 inputs required to generate this number of combinations. If you look, we've done this a lot of times before. The inputs for logic, when there are 2 inputs, go 0, 0, 0, 1, 1, 0, 1, 1. And now they want you to complete the truth table. So they're asking you to look at what happens to the outputs. So if you look, the blue, I'm going to just flick back up here. The blue goes off, on, on. So on my truth table, it goes off, on, on. So now I need to do the red. The red, if you look, goes off, off, on. So down here, off, off, on. And then I want the green. So the green goes off, 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 on. So down here, off, 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 on. So these here, these columns here, relate to the rows here, which gets a bit confusing sometimes because you're converting kind of a horizontal pattern here into a vertical pattern of numbers. A few people then got confused with the bottom bit. Now it's asking you to complete a Boolean expression for the different outputs. So these outputs going down here. Now a Boolean expression is a way of writing out logic circuits, but writing them out in a kind of mathematical way. So again, you could look at the Educas ebook, chapter 6. But you can look it up online, but I'm going to just write down here what I know Boolean expressions are, so that I know that a not would be something like an A or a B with a bar above it. That bar means not. And is A dot B, that means A and B. Or, bizarrely, is the plus sign, so or is A plus B. If I want NAND, it would be the AND gate, A dot B, with a line all the way across it. And if I want NOR, it will be the A plus B with a line all the way across it. So now I can try and work out what these are. First thing I've got to do is I look at the outputs. So it's 0, 1, 1, 1. Now I know straight away, because I've done this a lot, I know straight away that that's an OR output. I can work it out if I'm not sure, because 0 and 0 input here gives me a 0 output, a 0, 1 gives me a 1, 1, 0 gives me a 1, 1, 1 gives me a 1. So when this one or this one or both of them are on, it gives me an output of 1, and that's an OR gate. So X equals B or A. So it's B or A have to be on. Now in Boolean notation, it means that X equals B plus A. Okay, so because this stands for OR. Right, the next one. This is in a way the simplest and the hardest one. Study the Y output. So it's 0, 0, 1, 1. Now from all knowing all my logic gates, I know that there isn't a single logic gate that will give me this, so I'd have to combine logic gates. But this is where you have to be really careful, because sometimes the more you know, the harder you make it for yourself. And there's actually a really simple solution. And the simple solution here, if I look and I try not to combine these two inputs, if I look, 0, 0, 1, 1 is actually just the B input. So I don't need to use A at all. It is just that Y equals B. So I don't need any logic gates at all. Y equals B. It's just a direct correlation from one to the other. I don't need any kind of logic to combine that. Now, like I said, that's the bit that people find hard. The more you get to know, the more you try and make something up to fit this, and you really don't need to. Okay, last one. Z 0, 0, 0, 1. Now again, I know that that's an AND gate because I just remember them all, but I can check. 0 B, 0 A gives me 0, 0 and 1 gives me 0, 1 and 0 gives me 0, 1 and 1 gives me 1. So the only time it switches on is when B and A are switched on, and that gives me an output of 1. So I know that Z equals B and A have to be on. So in Boolean notation, that is Z equals B dot A. Okay, so I hope that this way of explaining things helps a lot. I'm going to do some more little videos. They're all about between 5 and 10 minutes long for each question that you've done.